Hi everybody. In this video we're going to be looking at how to balance chemical equations. Now all chemical reactions obey the law of conservation of matter. So what that means is that the atoms are not going to be created or destroyed, they're just going to be rearranged. So you can see here that on the left side we have one carbon, and on the right side we still have one carbon. On the left side we have 4 hydrogens, and on the right side we still have 4 hydrogens. Same thing with the oxygens, we have 4 on the left, and then we still have 4 on the right hand side. We have 3 important rules to follow when balancing equations. The first one is to balance each element by adding coefficients only. Now the coefficients, those are the big numbers that are in front of the substances. We are never allowed to change the subscripts. The subscripts are part of the identity of a substance. So for instance, this 2 in H2O always will have to be there. And the last thing is that the coefficients also have to be in the simplest whole number ratio. So let's give it a try on trying to balance the equation that's above. One of the first things that you notice is that the hydrogens are okay because I have 2 hydrogens on the left and I have 2 hydrogens on the right, so that is balanced. But there's 1 oxygen on the left and there's 2 oxygens on the right. So what we're going to do to balance that is we'll put a 2 out in front of the water. But that messes up the hydrogens. Now I have 4 hydrogens because it's 2 times 2. And so I'll have to put a 2 in front of the H2. And then this one is balanced. Let's just take a quick look at rules 2 and 3. And I think what I'll do is let me just erase the coefficients that we already have there. So if we're never allowed to change the subscripts, what that means is that back at this point, the oxygens were not balanced because I had 1 oxygen on the left and 2 on the right. And so we would not be allowed to balance off the oxygens by changing the subscripts, for instance putting a 2 for H2O and then transforming that to H2O2. H2O2 is a different substance, it's hydrogen peroxide. So that would not be allowed. I'll take that back out. Now here's another thing that you would not be allowed to do. This is kind of looking at rule number 3. We had seen before that the correct answer was having 2 H2Os and 2 H2s, and that's a balanced equation. So what we would not be allowed to do, though, is if we had, let's say, 6 H2Os, 6 H2s, and 3 O2s, that it's still a balanced equation because we have 12 hydrogens on the left, 12 hydrogens on the right, and there are 6 oxygens on the left and 6 oxygens on the right. However, according to rule number 3, we're not allowed to have this as a balanced equation because it's not in the simplest whole number ratio. So let's just get that back. We'll take out the 6's and the 3's and get it back to the correct answer. Sometimes students struggle a little bit with balancing at first, so let me offer up a few key strategies. If you find that you have an element that's not in a compound or appears more than once on a side, it's usually best to save that element for last when you're doing the balancing. An example of this would be in the first equation. You can see here that oxygen is not in a compound, it's all by itself, it's in elemental form. Also, oxygen appears on the right hand side in 2 different spots, 2 different substances. So when we balance the first one, we're going to balance oxygen last. Another strategy is to look for least common multiple. You can see in the first equation that there are 3 hydrogens on the left and 2 hydrogens on the right. And so the least common multiple for hydrogens is going to be when we have 6 hydrogens. This technique will also be used in the second equation where we have 2 chlorines and 3 chlorines on the left and right respectively. Our third strategy is about polyatomic ions, and it is that you don't need to separate them. So in the third equation, you can see here we have NO3 appears on the left side of the equation, and it's still intact on the right side of the equation as NO3, and so we can just use that as one item and balance the NO3s. The last strategy about having an odd-even problem, I'll elaborate on a little bit further when we try to work on balancing the first equation. Okay, let's start that first equation. Now we already said we're going to save oxygen for last, so let's start off with the nitrogens. What we could see is that the nitrogens are already balanced because I have one on the left and one on the right. So we'll move on to hydrogen. This is the one where I said we have to use least common multiple. So I'm going to put a 2 out in front of the NH3 and a 3 in front of the H2O. That'll give me 6 hydrogens on both sides. But that seems to have messed up the nitrogens. Now I have 2 nitrogens on the left, but only 1 nitrogen on the right. So I'll have to put a 2 out in front of that. Now let's move on to oxygen and finish off the problem. Now I see that on the left-hand side I have 2 oxygens, and on the right-hand side I have 2 oxygens here, but also 3 oxygens with the water. That's going to give me a total of 5 oxygens on the right. Well, this seems to be the problem that's mentioned in strategy number 4. We have an odd-even problem because the oxygens can only come 2 at a time on the left-hand side. We'll only get even numbers for oxygens. On the right-hand side, we have a total of 5, and so this is the point where we're going to do is we're going to double all the coefficients that we have so far. So I'm going to double the coefficients that I have worked on so far. I have a 2, and a 3, and I'm going to double that to 4, 4, and 6, and then that's going to give me even numbers on the right-hand side. So let's wipe those out, and that'll give me 4, 4, and 6. Now let's work on the oxygens again. We have 2 oxygens on the left, and now 4 oxygens from the NO, and then 6 oxygens from the H2O. That'll give me 10 oxygens total on the right-hand side. So if I put a coefficient of 5 out in front of the oxygen, that'll give me 10 oxygens on both sides. Now that this one's finished, let's move on to the next one. I can see here that aluminum is by itself and copper is by itself, so those are excellent elements to save to the end. So I'll work on the chlorines, and with the chlorines I notice that I'll have to use least common multiple. I have 2 on the left and 3 on the right, so that'll give me 3 and 2 to get myself up to 6 chlorines on both sides. Then, since I messed up the coppers by now having 3 coppers on the left and only 1 copper on the right, I'll have to put a coefficient of 3 in front of copper, and on the other side I'll have to put a coefficient of 2 in front of the aluminum to balance off the aluminums. And then that one's finished. Let's go on to the last problem. Now in this problem I had told us before that for polyatomic ions we can just leave those together as a group, and so the OH and the NO3 I'm just going to leave together and kind of balance those as if they were an element. So let's get started. I think I'm just going to work left to right on this one since I don't see anything that suggests that it should be saved to the end. So I'll start off with the sodiums, and those are already balanced. Then we'll work on the hydroxides, the OH, and it seems that I'll have to put a 3 in front of NaOH, so that now I have 3 OHs here, and on the right hand side I also have 3 OHs. That seems to have messed up the sodium that I already had finished, so let me go back and fix that. We'll put a 3 in front of NaNO3. Now let's move on to aluminum. I notice that I have 1 aluminum on both sides, so that's okay. And now the NO3s, they seem to be fine too, because I have 3 NO3s on the left, and I now have 3 NO3s on the right. And so all those are balanced. Now there is another video following this one that gives you more practice with balancing, and so I encourage you to try that out if you're still having some trouble.